1 mole of an ideal gas with the adiabatic exponent gamma goes through a phototropic process. As a result of which the absolute temperature of the gas increases tenfold. The phototropic constant equals N. Find the entropy increment of the gas in this process. As a result of phototropic process, PV to the power N equals to C. The absolute temperature increases 3 times. N is phototropic constant. Now from first law of thermodynamics, dq equals to d plus dw cv dt plus p dv for 1 mole of gas. For polytropic process, dw integration p dv equals to integration c by v to the power n dv v1 to v2 equals to c integration v1 to v2 v to the power minus n dv equals to c into under bracket v to the power minus n plus 1 minus of v1 to the power minus n plus 1 divided by 1 minus n, or equals to p2 v to the power n into v2 to the power 1 minus n minus of p1 v1 to the power n into v1 to the power 1 minus n divided by 1 minus n equals to p1 v1 minus p2 v2 by n minus 1. Since p1 v1 to the power n equals to p2 v2 to the power n equals to constant. From ideal gas equation, P1 V1 equals to RT1 for 1 mole and P2 V2 equals to RT2. Hence dW equals to minus RGT by n minus 1 and dQ equals to CV dt minus R by n minus 1 into dt. Now entropy change delta S equals to integration of dq by t equals to under bracket cv minus r by n minus 1 into integration of t1 to t2 dt by t. Now entropy change equals to under bracket cv minus r by n minus 1 into log tau equals to r by gamma minus 1 minus r by n minus 1 ln tau, or equals to r into under bracket n minus gamma by under bracket n minus 1 into under bracket gamma minus 1 into ln tau. Answer. The expansion process of nu equals to 2.0 moles of argon proceeds so that the gas pressure increases in direct proportion to its volume. Find the entropy increment of the gas in this process provided its volume increases alpha equals to 2 times. Solution. From the question, the pressure is proportional to the volume. This implies P proportional to V or P equals to K into V, where K is a proportionality constant. Now from the first law of thermodynamics, dq equals to d plus dw. Now d equals to nu cv dt, where nu is the number of moles, and dw equals to integration p dv nu rt dv by v, as pv equals to nu rt. Hence dq equals to nu cv dt plus nu rt by rt into dv by v. Now entropy change ds equals to integration dq by t equals to nu cv integration t1 to tt dt by t plus nu r into integration v1 to v2 dv by v equals to nu cv ln t2 by t1 plus nu r log v2 by v1. This gives delta S equals to nu cv log t2 by t1 plus nu r log alpha. Now from the condition of problem p equals to kv, this implies p1 by v1 equals to p2 by v2. This implies p2 by p1 equals to v2 by v1. Also p1 v1 by t1 equals to p2 v2 by t2. This implies t2 by t1 equals to p2 by p1 into v2 by v1 equals to v2 by v1 to the whole square. From equation 1, delta S equals to gamma nu into r by gamma minus 1 into ln under bracket v2 by v1 का whole square plus nu r into log alpha equals to nu r into under bracket 2 by gamma minus 1 plus 1 into ln alpha equals to nu r into gamma plus 1 divided by gamma minus 1 into ln alpha. Answer.